Hello, welcome to our presentation on surfacing tips and tricks. My name is Mike LaFleche, also known as the Professor. I run the Innovators Insider podcast with my buddy Richard Doyle. Definitely check that out. But I'm joined today by my friend, industrial design consultant, educator, and author, Vince Haley. So Vince, he's been a great friend of ours over the years. And he's been very helpful with helping businesses and individuals like me and teams discover and integrate, establish, and take a look at computer-aided industrial design tools, surfacing tools, product development. So, really excited to have you on this great call today, Vince.
Thanks, Mike. It's good to be a part of it and work together some more.
Absolutely, yeah. I mean, if we look back at that previous slide. This controller Vince was responsible for with the Phenometry app and, some Onshape surfacing, back last year. You'll see this up on the main Onshape website. And thank you for contributing to that, to this process, Vince.
Very good. So just a quick little bit about myself. So I'm a skill development coach. What does that mean? I help people with surfacing primarily, and from a creative standpoint and a technical standpoint. And the slide on the screen now is just a range of product categories that I've worked in over the years, medical being a large part of that. And then the big chunk of my time right now is spent developing out the X-Year brand and all the products there I've done, and they've actually been modeled, constructed using either Creo or more recently Onshape. And then, as Mike mentioned, some collaboration with Phenometry and helping them flesh out that software from a user standpoint, as well as developing content. So that's the mix of things, and it's been quite exciting to be a part of the different development processes and helping people learn as well.
Yeah, I mean, you've worked for pretty, interesting companies like Whirlpool, New Rubbermaid, Stryker. I mean, there's lots of good stuff that you see here that it's quite a wide range of industries served. So pretty cool stuff. I love this bottle of whatever it is. It's really interesting.
So that was part of a content development exercise for Phenometry. We some assets that demonstrated the capabilities of Phi.
Absolutely. It looks great. And all of these products look great. And of course, we probably all have at least one of these things somewhere in our house. So today, obviously, we're talking about surfacing, right? Surfacing is something that we're always working on, of course, at Onshape. But over the last year or so, since the last Onshape Live 22, a number of very important workflows have been made available, and we wanted to go through that today. So we thought it would be a cool idea to kind of walk through like a VR controller, like you can see here on the screen. But it's we just wanted to be inspired by that, build something out, use all the tools, right, that come out in the last year or so. So most of the time we'll be talking about surfacing, but of course it wouldn't be Onshape if we didn't talk about PDM and of course the whole time going through agile process, collaborating with each other. While preparing, while watching the other presentations, Vince was collaborating with me on this controller, and we were able to see things update in real time, and Vince was able to help with that. So it was really cool to see that. But that's an image from our render studio. So this surfacing topic, who is it for anyway? Now, if you're here, you probably already know, right? You need control over the shapes that you're creating, right? You want to create exactly what comes to mind, what the market demands, whatever it is that you're looking to build, right? Designers need control, precision, and aesthetics. In your world, Vince, you mentioned you're a CAID expert, computer-aided industrial design expert, industrial design. You're like, what would you add, to this? Who is surfacing for? Obviously, people like us, but who else?
Sure, I think those who want to create geometry, obviously, is aesthetically pleasing, but also that's highly manufacturable, right?
Mm.
And then the question is, how do you deliver on both of those? So from an ID standpoint, we're coming at it from that angle of the aesthetic, but making sure that I can deliver on the different requirements. Um, so I would say really anyone with that kind of concern is looking to have high quality surfacing. Just the question is whether you know the tools and the different processes to achieve it.
Yeah, yeah, absolutely. And you can see on this slide here, there's a number of things that, kind of go into surfacing. Like, for this, helmet that we're looking at here in the southwest corner, you need good curves and good underlying, kind of structure to make all that happen. So we'll be talking about that today. We'll also be talking about, analyzing the surfacing, knowing what you have in front of you. Like you look at the back of the violin there, and you can see the curvature plot, right? The curvature continuity is something also recently added. And, we've done it in a really good way where you can see lots of different quantities on there. So really,
So
yeah, go ahead, Vince.
sure, my answer was from a product design, industrial design standpoint, but I realized there's a lot of makers, and sculptors and things like that who are now they have access to 3D tools and they're trying to figure out how can I make these highly organic shapes and using digital tools. And so I think that would be another category of users that would really be looking to take advantage of surfacing.
Excellent point. Excellent point. And, with the tools like Phenometry in our app store, that it's like a push-pull kind of concept, early on, product development, creating the shapes that you want. And in fact, it's very accurate as well, which is very interesting. You have that type of surfacing, and then you also have like the highly technical surfacing, like you see here. But, we're going to try to make it as easy as possible. So since Onshape Live 22, there's been a heck of a lot. It was like, it's all, it was the year of the product, as John Hirschtick was talking about earlier. But if you look at the things that have been added, Bezier curve, sketching, right? Big deal. The ability to flow better. We'll show all of these things. I'm not going to read off every single thing here today, but just know when I started thinking about putting this together with Vince, I wanted to like use almost everything that came out in that last time since we were together last year. So, being able to do all of these things, I could probably build something close to what we see here today on the screen, but it might have taken a different path, right? And I think the path that it took this time was actually really easy. So, let's take a look at this slide. And I'm not like the world's foremost industrial designer. I'm going to check my ego. All right. And if you look at this VR headset, obviously it's not, I tried to get close, and I tried building this with just traditional solid modeling features, right? They're fast and they automate things. You create an extrude, you create a revolve. It's doing a lot of stuff for you, but it lacks the control that you might need, to create, more sophisticated geometry, like you see
I
here.
think especially when it comes to getting the blends between the major component sections, the handle to the ring, and getting those blends, that's where you start to come up against it with just straight solid modeling.
Yeah, this is kind of embarrassing to look at, but it's without any of those blends, as you say, in control, it makes it much more difficult to get there. But now with these controls, and then the verification of the surface, to look at the to see the curvature combs and control grids and curvature maps and zebra in any direction you want. It's really nice to be able to understand what you have in your hand is going to be what comes out of the manufacturing process, right? And that's really good. So like just these things like bridging curves, 3D fit splines, things like that are going to be very powerful when you start getting into this. And of course, we recently introduced the boundary surface option in Onshape, and what that will do is give you a lot more control as well. So we're going to get into a demonstration. I'm going to jump into the document, for this VR, kind of inspired controller. But just know along the way, we're going to be doing agile process, right? We're going to work on branches. We're going to iterate. We have peer review, branch and merge, right? It get inspired agile process, right? So just keep that in mind as we go through this. So let's actually get right in to the demonstration, of this. And we're going to walk through, some of the things that we did in this design. So there we are. Here I am inside of Onshape. I'm just going to go full screen there. And, we see, the model, looks pretty good at first glance, right? You have nice, constant width fillets and things like that. But I'm going to go through a list of things that I think are very helpful in the world of surface modeling. And Vince, as you see places to commentate on this, please feel free.
Okay, will do.
All right. So, of course.
So by the way, the way we approached this was Mike built the model out, and he especially wanted to showcase the new surfacing features and how they could come together. And then from there, we started talking a little bit about a variety of approaches that could be taken and alternative surfacing features. So we'll try to bring some of that out as we go. Absolutely.
Because there were a few, you'll see this as we go through it, but there are a few places I may have taken a different direction. But, I wanted to go deep dive in the surfacing. I haven't done a lot of deep dive CAD surfacing work in a little while, so I was really excited for this opportunity. So, of course, here I am on the main branch, but I'm going to go into this design for manufacturability branch where I've been doing the lion's share of my work here. And I'm here at the assembly level of the document. One thing that I like to bring up, and I'm going to bring up just the comment panel to kind of cheat a little bit here, but it kind of gives us a good opportunity to go through each of the steps that we want to go through today. So first one right here, tangent line mode is a very, very nice option to have when you are looking at this type of geometry, because you see how we have these sharp kind of lines here. It might be more interesting to understand the geometry and to understand if it is indeed tangent. The surface is tangent, at least tangent, merging from one surface to another. So I like this mode a lot. I also like, sometimes turning on perspective mode when I'm, doing a quick look around, the model, right? So pretty good stuff there.
So the tangent mode is a little subtle, because I think what you're saying is the secondary edges that exist within the boundaries of the product, they're phantomed a little bit more so that you can see the transition between the surface patches.
That's right.
And then, of course, your outer edges are going to be bolder. I guess the other thing you could do is just turn off all of your outlines so that you could see the surfaces and their relationship, and that helps as well.
Absolutely. Yeah. So this was added, a little while ago, the ability to go phantom. It was in the part studio first, and then it came into the assembly environment. But just looking at this shape, Vince, I mean, where do you start on something like this? I mean, it's like this is there's not a lot of flat surfaces on this. Where would you begin? What would your thoughts be on this type of work? When thinking about where to begin.
You begin with some sort of reference. In our case, for this model, we actually had a unit that we could reference and that we could put our eyeballs on and say, hey, what are these surfaces doing, the relationship one to another, and then begin to have a strategy of how I'm going to model it. From an industrial design standpoint, often we'll have a series of concept sketches that we might bring in and draw those, whether it's a unique design or it's an existing product that we are updating. So that's another approach.
Exactly.
But so those are the references, but then you still need to establish a a strategy for creating those surfaces and studying the transitions and so on.
So where I started, and yeah, I was just trying to try out different things, right? Because I hadn't had a chance to dive in a little while at this level. And I was like, okay, let me start with a ruled surface. Instead of going the traditional loft, sweep, whatever it is, right? I drew a circle, right? Just gave it a diameter because I had my steel ruler out, and that was the first dimension I could easily pick. I think that was probably why I did that, right? So the thing I did next was create a ruled surface, just taking that surface, or that circle, I should say. And let me just show you, because it's really, I'm going to roll right to here. And then I'll roll back a couple more. When you do a ruled surface, and you'll see me use my type options quite a bit, it gives you the interesting opportunity to specify an angle. I could, go up or down, or I could just pick an angle, right? And it's going to give me perfectly analytical, like, straight lines if I were to cross section through that thing, right? So, if that's a requirement, and it's a requirement, and Vince and I, we were chatting about this earlier, this might be a fine way of going. But if it's not a requirement, if it's up in the air, like maybe you want to comment on that, Vince.
Sure. When I looked at this guy right here, down on the inside, it seemed like it was more a ruled surface. But
Yeah.
there's some subtleties on this outer part that actually have a slight crown to it.
Mm-hmm.
And so the ruled surface is going to give us a constant flat around there. So if I want to tweak that and create some curvature or compound curvature, then a different tool would have been better. But as Mike was saying, it got him out of the gate quickly to rough out the shape and then see it start to come together. But having flexibility to create crown, the ruled surface won't allow for that.
Exactly. And when you say crown, like, a slight bulge on that surface. Yeah.
Right. Almost every product, even if it looks flat, has some sort of crown curvature so that you don't get a sunken in look when the material, if it's plastic, settles.
Right. Any kind of dwell that happens on the plastic injection mold process, that I didn't realize that's why it was added. That's fantastic, actually. So, like, you can see, it's if I flip these stripes, they're pretty straight up and down on that surface. Of course, we could introduce some kind of crown if I was at this stage and I did a replace face or something like that.
Right.
With another
Exactly.
thing, if worse came to worse.
Right.
So yeah, and you can see I'm organizing things in the folders, logical folders here too. That's a great way of keeping track of what parts of the design you're in, I think, and it'll actually help me quite a bit when I roll through here, because now I can roll to all those different places. All right, so let's go back to a few changes ago. All right. So the next things that we were doing, if I go into my list right here of comments, I go right here. I did something pretty interesting, I thought, because I had never done it before, but the ability to take a piece of geometry like the faces right here, and I could project those faces, or that single line sketch right onto that surface. And we have a new option since the last Onshape Live was to introduce, putting it on normal to the surface. So that was something that I did earlier. I'm not going to jump into that. I also did a mutual trim to achieve the that ring section earlier, just to show you that was something that we introduced since last time as well. And you can,
the beauty of that is you don't have to use extra features now to delete the pieces that are left over, but they're absorbed when you do the trim, the mutual trim, and that's efficient.
Yeah, it's efficient because And I had to overbuild to kind of get what I wanted. I wanted to get, instead of doing a loft here, I put in another ruled surface, and I overbuilt it and just used the mutual trim to trim it back. So that's a typical technique we see often in this type of modeling. Now we're getting really into the thick of it. I think once we start getting into these areas where we're getting the blends involved, Vince, right? So if we were to, let me roll back here. One other thing that I did, maybe I'll just mention, was I created a USB interface. You see that little arrow there? That shows me, I had an in-context feature showing me where I was going to place a very important mechanical component in my surfacing. This was just a standard off-the-shelf USB-C, interface, right? So being able to place that in a kind of a blank assembly, I took the surface and put it in an assembly, placed it in context so that way we could see the exact location and shape that we wanted to have around that represented. And that really will help me later when I start blending in the surfacing later. But let me just get back over here first. It's just the order in which I did the design. And let's turn on some curves. And you have this manager down here to see what's going on here. So you can see I've built a number of bridging curves. So bridging curves are helpful. If I turn on the surface model again, they're helpful because I can actually go in and create, from one point to another, or one edge to another, a perfect 3D curve that will either match at a position, at a tangency, or at curvature, C0, 1, or 2, right? So, the curve is doing this for you. Instead of like trying to whip in 3D sketches and things like that in other CAD programs, you would use the bridging curve to give you that precise control. And it's quite controllable. Like if I go in over here, take a look at this curve that's coming in, you see I can control it either by magnitude and bias or by control points, where I can just push and pull on that, right? Of course, the nice thing about Onshape, if you've used it a little bit, is the final button, which shows you, what it looks like. But it's not going to show me the final in this result because I've rolled back in time. It's actually not bad because, sometimes it makes a lot of sense, if I cancel this, to not, you don't want to rebuild the whole feature tree, right? You just want to kind of see what it does up to a certain point. You can roll it here and then start playing with the curvature, right? So now as I drag and drop or drag these arrows around, we're going to see the surfacing start to blend right up to that curve that's being placed in there.
And all of this is because you have your USB region, a flat area that will receive that USB. But now, how do I blend my handle on the end and so that it flows into that region, and I can have some control of that blend? And so these curves that you're laying down right now become the boundaries, and they have the smooth connections that will allow the patch region to blend well to the handle and yet follow the shape.
Yeah, let's dive into that. Thanks, Vince. So,
Mhm.
We have the boundary surface here is our friend for this, right? So the first thing we needed to do was, create, in this case, the flow that I took, it's almost like building a puzzle, was, to create the top surface here where the interface is, and the ring kind of surface is up here. And I knew I wanted the blend to kind of stop here. So I placed a curve that split this face on here, right? So essentially you can do a curve to face split now. And that's possible since the last Onshape Live in 22. The ability to just get that right on that surface and split it. You could do these things before, but as you said, Vince, earlier, you would be multiple steps. But now it's a single step for that. And then, I have this boundary surface. I want to go from this curve to that curve. So to do that, you can do a 2 profile just in what they call the U direction.
Zoom out just a touch so they can see the grid on that surface there.
Yeah. Yeah. So this is the first surface.
And note the grid is the U and the V direction is pretty regular and divided evenly, and that's something that you want to see on your surfaces. And there's not much tension, but it's flowing nicely. We have another on the other side. Let's try to remember, Mike, to show that one, and for a comparison, we can talk about how you can control it better.
Yeah, exactly. So let's go over here. Yeah, I was trying to come up with like the exact flow, because I was kind of looking at a built model to do this. What kind of flow would give me the shape that I wanted, the way, I expected, right? So, at first I did a lot, I did a boundary surface, but it was, I wanted to give it, these guides to kind of keep it trim, but it's getting tight over here, right? And that's going to be hard for any software to kind of figure out, in one step. So you can see the first surface, I overbuilt a little bit as a boundary surface. Once again, same technique going from, one edge to another with the nice, it's got the nice grid. But then I needed to split, using that same normal to target split tool. I created those bridging curves initially, right? To go from that endpoint right to that edge. And then manipulated this until I was pleased with the visual of it. And then, of course, we can physically split that out now, as I showed you earlier on the top of the ring. So that, and then just clean it up.
So your bridge curve, you were able to achieve the blend that you wanted and the tangency, the continuity that you wanted. However, I think your original intent was to use that boundary, use that profile in the boundary.
Yeah.
But it put too much tension on the surface.
That's right.
So then you trimmed it back, which brings up two different approaches. Either you can build to boundaries, or you can overbuild your geometry and then trim back. Both of them are valid. But visually, if you build to boundaries, then you see exactly what your shape is going to be and its exact relationships. And so I try to do that as much as possible, and then overbuild as a secondary approach.
Exactly. And that's what we did down here. It was more like that approach. It was getting that USB interface, perfectly split out for the boundary surfaces. And this one, we had the U and the V profiles. So we were able to put the curves in first, use the existing edges of the surfaces from the flat to the interface. And of course, you have the ability to match tangency, magnitude changes can be set, but this looked like a very pleasant transition, by having it trim right to the boundary, right?
And it's that magnitude adjustment that's going to let you dial in your transition and also the way the highlights flow around that end piece, whether you want them to look more abrupt or whether you want it to be a subtle transition. So the magnitude, changing that is one way to dial that in and tune it.
Yeah, and it's still keeping it tangent here, which is quite nice. Yeah, so I'll just cancel that. But yeah, so this ended up coming in nicely because of that direct technique. All I had to do was hit the unclose button and just filled it as a solid, and then you go from there. So this is obviously too short a session to go through the whole design of this, but you're seeing a lot of the interesting ways you would go about this. The other thing I want to make sure we get to, because I know time is flying right now.
It sure is.
We have this done. And you notice how I kept the feature count down? We're at 80 features for this shape, and I've even kind of painted in where the interface would go. That I'm doing this on a separate tab.
I'm a numerous feature kind of guy.
Hey, it is the way it is, and there's so much that goes into it, but there's only so much rebuild time. If you can kind of try to parallelize it just a little bit with this technique by doing a import derive of the kind of.
So on that point of multiple features, spin the model around, Mike, and show where the trigger is at.
Oh yeah, there's a
Um,
comment here.
yeah. Uh, so the one question, just in general, was, are we going to put the trigger in? And then the other thing, which I didn't type in, was, is our profile, does it correspond to the profile in this one, since we had it? And it's softer here. I don't know if Mike's able to. Can you jump to
Yeah,
the other branch and
absolutely.
just show the refinement there? And it came to mind now because it required some extra steps in order to accomplish the overall um, aesthetic and formal um, structure that we wanted. So this trigger is roughed in. It could be refined, but the opening, and if you spin around,
Oh
you can
yeah,
see that
yeah, yeah. Watch
yeah,
this. This is let's. Where is the? Oh, never mind. Go ahead.
that's yeah, just that's all I wanted to say. Sometimes you have to put some extra steps in there in order to accomplish the details that you want. And so
Oh, I see. So you kind of roughed it out, like, you had a nice kind of extruded shape
yeah,
like this, yeah, and
yeah.
then you're taking this curve, you're sweeping what looks like a
Sweeping that
surface,
curve, doing a replace surface to get the curvature on the bottom of
yeah,
of the trigger,
yeah.
and a sweep across the top. And again, this setup is more roughed in than it is a refine. In fact, we put it in just this morning, right? And
Yeah.
said, okay. And so we were able to at least show you. And I just used a typical, a variable round, and that edge that tracks around there, it changes a little bit more than my liking. And that would require a custom blend as well to get the transitions. But
Yeah,
we roughed it in, could go from there.
not bad while we're watching the other sessions on Onshape Live.
Yes.
But yeah, this is, the other thing I just want to mention before I get to the questions is, like, use the appearances manager when getting into this kind of stuff, when you're painting in the, things like this, logos, things like that. It makes it very easy to understand the different colors in your interface. So definitely take a look at that. Look at variable studios for common things across your document or even other documents. And then, of course, it wouldn't be consumer product design without any kind of rendering right here. So here's a rendering right out of the rendering studio. This is using the advanced version of the render studio, where I was able to get a 4K image, set this thing, all the things that you see here as far as like the reflection on the bottom without any surfacing and all that. Some of that stuff was added this year as well. So that went by really fast, Vince.
It did. Just flew by.
It just flew by. So there's a number of people that are asking questions, and I think the best part of this session is to answer the questions when we have a industrial design expert on the call here. So Nacho, are there any questions from the audience?
Yes, we can start with a pretty simple one. Ben Druce asks, cool model, love it. Any chances you'll be able to share the link to this so that we can learn about how you built it?
Yeah, I would be happy to share this link with anybody. So it's not any kind of intellectual property. This is just something inspired by something I had on my desk. So yeah, absolutely.
Awesome. We'll make sure to get that out there. There was another question about the differences between overbuilding a surface and then trimming it versus constraining the surface fully as you're building it, and what the benefits would be to both approaches and would create the best surface finish.
Both yield similar surface finishes. As I mentioned earlier, I typically try to build to boundaries, simply from the standpoint I can see exactly what the shape is of the object, as opposed to what would be sort of like a reveal, when you overbuild and you overbuild several surfaces and then you eventually trim them out, then after you trim it out, voila, it looks like what you're after. But I like to see real time what my shapes are. And one other thought there is, more than likely, had I started this model from the beginning, I would have made an armature that could have even been a simple line that represented the angle of the handle and a line that represented the angle of the ring, and have that parametrically set, and then hang all of my details on there, so that if asked to change that angle because we have some components that need to fit in there, and or the ergonomics weren't right, then you can change and update. I thought I would comment on that.
Yeah, that makes a lot of sense. If I were going to do it again, I would definitely do it that way.
Awesome. Thank you. Mohammed asks, what are some ways to use control splines to manipulate a surface?
Control splines. So I did that on this particular design on the back of the handle. You'll see it in the link that I share later on. But, you can use, I think it makes a lot of sense. Actually, I'm going to show it because.
Is the question asking about Bezier versus point splines?
That's where I'm going with it. But
okay.
let's go back to the DFM branch here. And if we can just go full screen there, yeah.
And while he's looking for it, the through points is going to put the curve exactly through the points wherever you lay them down, as where the Bezier, has the control cage, and you get real fluid lines and when you use the Bezier. But go ahead, Mike.
Yeah, you can see it right here. I have this thing called back adjust, and I use the Bezier spline to do this. You can see the control kind of grid or points here to do that. And I flaked it through, if that's a technical term.
You made that up.
I actually pierced it right through these curves right here. And this gives me a great deal of control. And then this is, once again, the final button. When you have it just rolled back to a certain point, will make this actually really fast. And of course, you can do all of your curvature visualization stuff while you're in this mode, right? Curvature, color maps. Let's go turn that on. Oh, it's working on it. There's a number of bodies it's working on.
I can't recall, Mike. Is that a loft or a boundary blend that creates that face? I don't remember at the moment.
This was a loft.
Okay.
Yeah, so we picked a loft in this case because we had that center line. We had the beginning and the end curve. And the way the boundary surface works right now is that you just give it the beginning and the end, and that's it. The loft and has a number of other options. As you can see right here, and it still produces a very nice looking grid here. As you can see, the ISO curves turned on, and you have the ability to set a number of controls. The guides are all here, and I didn't set any continuity on these because the continuity was already defined. There wasn't any need in this case actually. So yeah.
On this model, we didn't particularly show a parting line, but sometimes what I do to find a parting line, especially on an organic shape, is I use my draft analysis and then orient the draft direction, and then it'll show where the virtual parting line is, and then you can begin to design to that. You'd have to determine what angle the handle was going to be molded from.
Yeah.
And then put a plane in that order.
And I actually used Devin Reese's mid curve feature, custom feature on this to try to do a parting line, and it worked great.
Okay. And what's that again? I'm not familiar with it.
Yeah, it's the let's see if I can find it because I know we're running out of time.
How about we see if there's any other question?
Yeah. While we're waiting here, we can go speaker screen again if that's okay.
I think that there's quite a relevant question to what you were just showing, which is how do we interpret the color map and new curvature analysis tools?
It's a great skill to have. There's a number of quantities that you can select for this. It's, there's Gaussian plots, there's minimum radius checks that are curvature based. So you can actually physically see where things are, but you don't want to have too much bunching in, like you don't want to have sharp curve. Maybe you do. I mean, it's up to the design, right? Maybe Vince, you could comment on this.
Well, what's coming to my mind right now is the surface that we created around the big disc. That's this guy here.
Yeah.
Because initially I used I saw that there was a fill surface, and that fill surface had a guide curve that was vertical and one that was horizontal. When all of those were picked, it yielded more of a radial flow of the U and the V. And then when we turned on the evaluation, we could see that the surface was kind of distorting in the middle and peaking. And for myself, that's how I use those analysis tools to see if the surface looks like it flows smoothly or not a lot of change in color, especially if it's a low crown, a surface with very little crown, like what we're referring to.
Yeah, that's great. Yeah, but it's there to help you understand these subtle kind of transitions that you might not be able to pick up by eye as well. Like, so, yeah.
And I would say those tools are used. So you've got beginning, intermediate, and then advanced users, and those users are developing this geometry and tuning it for as you get further down toward the manufacturing end. But I guess I'm trying to say, don't get hung up too much. If you look and see your ISO curves are flowing smoothly, and then your basic shading looks smooth, then you can keep going. It's when you're really trying to dial in those surfaces and so on. And sometimes for example, if you use a spline through points and it's bumpy, then your curvature display is going to show you those little peaks and valleys that may be subtle, but are really there.
Yes. Yeah. Makes sense.
We are starting to run out on time, but I'll just ask one last question, which is, can you explain the differences between fill and boundary surface?
Yeah. So fill allows you, it's an insided patch, right? So you could do 3 sides, 5 sides, right? And that's the way the math is built for that, where the boundary surface works off of pairs of curves in each direction, like parallel direction, right? So that's the way the math is designed for that particular feature.
And that fill will force your patch to flow through the boundary of no matter what the shape is. And it usually yields a good result. And then as well as you can get the connections that you need between the adjacent patches. But I think what Mike said with the being able to pick 3 sides or 5 or 6 and still have it fill that region in is nice to have.
Yeah. I would encourage you to try it out. It's very easy to build something and see what the differences are. So you can try it out. It's very easy.
If I'm remembering right, our current boundary plan, internal curves aren't allowed yet. Is that correct, Mike? Like guide curves on the boundary plan.
Right. So yeah, definitely look forward to the sneak peek and things like that.
Okay. All right.
Yeah.
Because a fill allows for that. That would be one difference. If you knew you had some other controlling shapes that you wanted to include in the patch.
That's right. Exactly right. Well, I think that's all we have time for. Maybe we can put one thing back up here on the screen, if that's okay, just to remind everybody about the offer for Onshape Live. So if it hasn't already run out, first 100 registrants that to use this code Onshape Live for LiveWorks. I'm going to be there. I'll have a presentation with one of the Onshape customers that you saw earlier with the NeoBot with AvidBots. So that'll be a lot of fun for me. And but I'm really going to enjoy seeing everybody here in person. So if you can make it to Boston in May and spring, it's the most beautiful time of year in Boston. Just please show up. It's going to be great. But Vince, I really want to thank you for joining us today and providing your years of experience, to this particular topic and helping me, with this design as well. It was really good to have you on my shoulder, helping with the design process.
You're welcome. I appreciate the opportunity.
Awesome. Thanks again, everybody. Hope you have a great day, and see you next year.